Welcome everyone. So this is our 73rd live stream geometry. We have five other people here with us already. And today I'm going to take problems from a pamphlet created by I believe he's a retired French professor, Jean-Louis Ayme. So he posts a lot on the Art of Problem Solving forum, and he has a website with a huge collection of different problems and theorems. So I took them with his permission. His AOPS username is JAYME, and he said he's going to go watch the video after we finish the session. So with that, I'm going to share my screen. And if you'd like to join us in future sessions, feel free to email me at mgreenb801@gmail.com. It's in the description of my video. We meet every Sunday at 8 a.m. US Central Time. All right, so I'm going to share my screen. Sorry, one sec. Let me share just the GeoGebra. All right, can everyone see it? All right. So here's the first problem. So we have a triangle ABC with circumcircle gamma. And then we want to see where does the A angle bisector intersect arc BC and the segment BC. So I'm going to draw that in. So we have let's draw the bisector. There we go. And basically M is like the midpoint of arc BAC because MN is a diameter. So we have this point is N. Can you guys all see it okay? Just want to make sure.
Yeah, we do see it.
Okay, thanks. All right. And I'm going to reflect N across that point to get point M. I'll call this O, and I'll call that M. So MAN is a right angle, obviously. BM and AN intersect at X. So that's X. And then we draw the circumcircles of ABB and XBN. So this and this. I wonder if this circle passes through O. I'm not sure if, I doubt that's true. Yeah. So let me draw it more like that. And these two circles are supposed to intersect at point E. So that's point E. We want to show that the reflection of N over BC lies on the circumcircle DNE. Okay, so if I reflect, basically, if we let N prime be the reflection of N over BC, we want to show that D N prime EN is cyclic. Let's check if that's true. Yes. So I'm gonna change the diagram just a little bit. Let me make this a little more slanted. There we go. So Dn prime n is isosceles, right? So is there a way we can think about this? So we want to show angle DEN is equal to angle DN prime n. but that's the same as dnn prime. So yeah, I wonder if there's a way we can think about this. Let's see. Is ADON prime cyclic? Let's see. Yes. Is that, maybe that's just an angle chase? Oh, it's obvious by power of a point, because NB times NA is NB squared, which is NO, yeah, times NM prime. So yeah, it's true by power of a point. So yeah, let's actually make this segment all the way to M. So is O collinear with N and N prime? Yes. Because N prime is just a reflection of N over BC, and N is like the midpoint of arc BC. So yeah, those are all going to be collinear. All right. Yeah. Okay. So yeah, how do we calculate angle DEN? So angle DNN prime is ANM, which is ABM. We want to show that's equal to DEN prime. I wonder, yeah, how do we find angle DEN prime? That is the key. Or DEN prime, either one. I wonder, what if we try this? Oh wait, are D, O, and E collinear? That would be interesting. Let's see, I wonder if that's just a coincidence. Let's check. It looks like it. Oh, it's not true. Okay. So yeah, I'm gonna go delete that. I see someone new just joined, Satvik. So thanks for joining. Oh, yeah, it's always nice when people bring along their friends. All right. So yeah, how do we show, what do we know about point E? We know angle BED is A over 2. So really, I mean, it's probably worth drawing this point right here, because we know BD equals DF. I wonder if BDN prime is congruent to NDF, because two of the sides are the same length, and maybe you could angle chase the others. So let's see, if I look at angles here, what's angle BDN prime? You have to do it counterclockwise. I always forget that. So this is 103 degrees. And this angle, so yeah, they're not congruent. BD equals DF and DN equals DN prime. Let's check point E. Is there anything special about point E? Anything that we can say? Not sure yet. So yeah, that does not actually pass through O. So maybe that's a better diagram. Right. Let's see. Could we?
What we have found till now, can you please tell?
Oh, sorry, I can't hear you that well. You can also type it in the chat too if it helps. Let's see. Oh, this is our first problem. So we proved that the only thing we really proved is that this is cyclic. So AN prime OD. And we also know that BD equals DF. But yeah, other than that, we haven't done too much. Let's see. Can we try to show that angle? If we prove DEN equals ADO. Are you sure ADO? I think maybe you mean angle DEN is ANM, which is oh yeah, DAO. Yeah. So we want to show, yeah, DEN equals DAO. Yeah, that's true. Maybe. Yeah, let me think about that. So can we try to make a cyclic quadrilateral out of that? So, oh, I think maybe AO and EN meet on that circle. That might help us a lot. Yeah, I think that's gonna be part of the solution. So Yeah, it looks like those meet on the circle. And I'll bet that's probably not that hard to prove. It doesn't look like it would be. And so if we know that, that would probably be very helpful.
Actually, AC and MN also meets on the circle.
Oh, really? Okay. Oh, yeah. And once we know all,
We can prove, yeah, we can prove it by an angle chase.
okay. Yeah, you just need to show the angle between AC and MN. Would have to equal, oh wait, so angle BXN is half of arc BN plus AM. And yeah, that would be the same as half of arc AM plus arc CN, which would be angle NHC. And then probably, this is probably also cyclic, AXHM. Yeah. So yeah, we have a lot of information here. This is probably enough to solve it, I'm sure.
We can do it easily. I can tell you. Just note that angle BN will be equal to angle BMN.
BMN.
Will be equal to BAN.
BMN.
And we have that angle XH is equal to angle BAN. So we have that the particular AXMH is cyclic.
Okay. Yeah, that proves that that's cyclic because that angle is equal to, yeah, to that angle. BMN is, yeah. All right. So MN meets AC, and Khan just gave the proof of that. And then Anurag just explained why this is cyclic. So yeah, we just have to prove the last step. And so, okay, so that was the same as showing that angle DAO is equal to DEN. So, which is the same as saying that DGEA is cyclic, which, yeah, okay. So once we know DGEA is cyclic, did we prove that? I forgot.
We didn't prove that till now.
Okay, so I should probably hide. So yeah, I'm getting a little confused. So yeah, really we have to show that G lies on this circle. Let me delete point F. Well, I don't know, maybe point F would be useful, it's hard to tell. But yeah, we have to show that point G lies on that circle. So actually, I wonder, do we even need to show that? Oh, I think we do, yeah. I mean, that would be equivalent to solving the problem if we could show that. So yeah, we can calculate angle DFA. Can we show that's equal to angle DGA? I think we're very close.
Yes, there is something.
DGA is 180 minus B. But that assumes that we already know the circle exists, and we don't. Basically, we need to prove that G lies on this circle. Is there a way you can prove that angle is 180 minus B? So like if I hide this circle, can you show, so DGA, yeah. So yeah, maybe I should hide that circle just for now. And yeah, we need to show that G lies on that circle. A, B, D, G, well, yeah, I'm going to draw the circle back in just because that's how E is defined. But is there something else special about point G? I wonder.
What do you define to be the point B, point G?
So I define G to be the intersection of AO and EN. So really I define E to be the intersection of these two. And then I want to show it lies on the circle ABD, EF. So there's a circle through the other 5 points. I want to show that G lies on it. I don't know if that's, maybe there's an easier way to do the problem. Maybe I could define G differently. Like maybe I could just define G. It might be easier to do it like this. Like I could let G be the intersection of AO with this circle. And then I want to show that E, G, and N are collinear. That would also work. And I wonder if AG is an angle bisector of DAF. I don't think it is, but yeah, no, it's not. Our F. Well, I think we actually want to show that E, G, and N are collinear, not F, G, and N. But I'm not sure if that can be angle chased. Yeah. Or how. So BAO is 90 minus angle C. Okay. That's true. BEG is 90 minus angle C. Okay. Oh, I like that. And then BEN is BXN. Oh, okay. I think that solves it.
This proves the collinearity.
Yeah. So I think that solves the problem. All right. So I'm going to start typing it up. And I don't even know if we needed point H really. So maybe I could delete point H. Let's see. I'm going to hide it. I don't know if we needed this circle either. So I'm just going to hide this stuff for now. And let me make room for the solution. Did we even need that this is cyclic right here? I don't know if we needed it. All right, so I'll say, and I don't think we needed this point either. Okay, so let's see how this works. So I'll say, let AO meet the circle ABDE at G. Because angle BEN is the same as angle BXN, and that's half of arc AM plus half of arc BN. And that, I think that should be easy to, yeah, so arc BN plus arc BMN is 90, so yeah, so I'll type it out, but so let AO meet the circle ABDE at point G, and I'll say let N prime be the reflection of N over BC. Oops. And okay, so angle BEG is equal to angle BAG, which is BAO, which is 90 minus C. So is this solution really that simple? So angle BEG equals angle BAG equals angle BAO equals 90 minus angle C. And then we also have angle BEN is equal to angle BXN. Angle BEN equals angle BXN, which is equal to arc AM plus arc and that's 90 minus angle C. Let me think about that a little bit. So BEN is BXN, and that's half of AM plus arc BN. And so BN is like A over 2, and AM
It's B over 2.
AM is okay. So let me think about this, because so arc AM plus arc BN. What's the best way to? So AM. So this is like 90 minus. Is B over 2 minus C over 2. Okay. Yeah, that's just, yeah, because this is half of arc. Okay. Yeah, I'll just leave this right here. I think the viewers can figure that out. So, okay, so Angle BEG equals angle BEN, so it's cyclic. It's all right. So I'll say and that means BEGN is cyclic. What did I do wrong here? Angle B, oh, I forgot to put angle. So we could draw that circle. Oh wait, BEG, no, sorry, what am I doing? This means that EG and N are collinear. And then once we know that, then we have an angle chase because we have angle DEN is angle DEG. Yeah, so DEN. So we have DNN prime is DN prime N is DNN prime, which is ANO, which is NAO, which is DAO, which is DAG, which is DEG. So yeah, so right now it's just all an angle chase. So angle DN prime N is equal to angle DNN prime, which is equal to angle ANO, which is angle DAO, which is angle DAG, which is DEG, DEG, which is angle DEN. So we have that whole thing. All right, I'm going to split it up into two lines. Let's see. All right. And that means that DN prime, NDN prime E is cyclic, which solves the problem. Applies the reflection of N over BC lies on the circle DNE. All right, so I like this idea. Yeah, the solution was actually less complicated than I thought. Yeah, you can share your solution.
Can I just present it?
Yeah, sure.
Mike?
Yeah.
Okay, so I won't be using point G, so can you delete it?
Yeah.
Like temporarily, or maybe you can add it later.
Yeah. All right.
And can you temporarily hide the circle BXN?
Yes.
BXN, because I will prove that the intersection of AC and MN lies on that circle, so we gotta hide it first.
Okay.
Okay,
All right.
can you call the intersection of AC and MN?
Yes.
So we have angle AIM is 90 degree minus angle ACB.
Okay. Yeah, because this is a right triangle. Yeah.
Yeah. And AXN, it is angle BAN plus angle ABM.
Okay.
So let's do an angle chase, and then we will have AXIM is cyclic.
Yeah. So yeah, AXIM is cyclic.
Okay, so we have MXI is equal to IAM is equal to CBM. So IX is parallel to BC.
Yes. IX
So
is
in other
parallel.
words, XI is perpendicular to IN.
Okay.
And we also have that NB is perpendicular to BX.
Yes.
So I must lie on that circle.
At BXIN. Yeah.
Yeah. And can you just show the circle?
Yes.
Oh, okay. So next I will call the intersection of this circle with AB.
Okay.
Okay. So I will redefine point N prime. So I will let the circle E and D meet MN at N prime. And then I will prove that N prime is the reflection of N over BC.
Oh wait, sorry. So what's the okay, so basically you're redefining N prime to be the intersection of the circle with MN.
Yeah, and then I'll prove that it is the reflection.
Okay.
Can you label the midpoint of BC?
Yes. So yeah.
Okay,
But-
so my
But then we
claim
don't
is
know
that
so sorry, but then we don't know that these are all we don't know that N prime if we define it that way, we don't know that N prime lies on this this segment, right?
actually we do because we know I'm calling N prime the intersection of circle NDE and the line MN, so it must lie on that line.
Okay, sorry, I got confused. All right.
Yeah. My claim is that I will prove that quadrilateral EIXJ is similar to EN prime DN.
Okay.
So and then because we have XI equals XJ, this is easy to see.
Xi is equal to xj. Yeah, because this is an angle bisector. Let's see.
Yeah.
So by symmetry, it's probably just
because the circle with that is the circle with the diameter xn. So by symmetry, it will be that xj equals xi.
Oh, interesting. All right, that's a cool way to see it.
Yeah, and then we just need to prove that the two quadrilateral is similar, and then we will have dn prime equals dn. Then k must be the midpoint of n prime.
Interesting. So you want to prove that xjei is similar to en prime bn?
Yeah, exactly.
Okay.
And it's just easy angle chase.
All right. So yeah, as you got enough of the other angles, and then it proves it. You like similar quads, yeah. I like similar quads too. That's a cool solution. Yeah, I should use similar quads more. So yeah, I'm not going to type up the whole thing, but yeah, thanks for sharing it. I like that. All right, so I'm going to move on to the next one. Let's see. Going back just for my YouTube channel. All right. So here's the next problem. Yeah, Buratino's problems are harder. I agree. So we have a triangle ABC, and we draw the circumcircle and the end circle. All right, so here's the circumcircle. And now let's draw the end circle. Let I be the end center. And so M is the midpoint of BC. And N is the midpoint of arc BAC. So I'm going to use the perpendicular bisector tool. Why not draw both points, right? So I'll draw this point and this point. So yeah, we're starting out kind of similar. Let's this be point D. Let the circle AIN. So let me draw in a couple segments. Whoops, didn't mean to do that. So yeah, this is looking very similar to the last problem, right? We have this circle, and then this point was in the last problem. Hold on just a second. Let me close this. Okay, so in the chat. Yeah. So this circle, we want you to be the center of it. And we want it to intersect this circumcircle BIM at point K. Oh, but I don't think we had the in center in the last problem. So something I think might have been different. It almost looks like they're tangent, but we don't want them to be tangent. We want them to intersect at point K. And then NI intersects BK at Z. So it looks like NU and I are collinear. That's obvious because this is a right angle. So NI intersects BK at Z. And we want to show AUKZ is cyclic. Yeah, this doesn't look that hard, but we'll see. So let me make these segments. I see we have some people typing in the chat. Does AK pass through the mixed linear touch point? So we want to see if AK and IN meet on the circle, basically. I don't think so. No. Would have been interesting, though. All right. Whenever you guys type emojis, it just looks like a little rectangle for me. I can't see which emoji it is. I'll be right back. All right. Oh, it's a pink bird. It's your avatar. All right. Okay. So AUKZ. So, I mean, we know angle KUZ is angle KUI, which is half of, or twice angle KAI. So, is that right? So basically we want to show AI bisects angle KAU, I think. No, is that right? I don't think so. I think I messed up somewhere. We want to show KUZ is KAZ. But KUZ is KUI, which is, so I think we want to show AI bisects KAZ. Yeah, that's what we want to show. So we want to show BAK equals CAZ. I think that's right. So BAK, we want to show BAK equals CAZ. Yeah. And that would solve it. We want to show AK and AZ are isogonal. I don't know if we could use the isogonal line lemma or something. Oh, the isogonal line lemma? I don't know if that's in that. Is there something special about this point right here? I don't know. Oh, really? Yeah, maybe K, I was going to say maybe K and Z are isogonal conjugates, but they're not, because they're not from angle B. Yeah, I'm trying to use the isogonal line lemma. But I'm not sure how good of an idea it is. Maybe, I wonder if IK and this point are collinear, the tangency point. It almost looks like it, doesn't it? But yeah, it looks like those are collinear. It's hard to make it so that they're not. Yeah, it feels like that has to be true. Is that obvious that I, K, and F are collinear? So we want to show that I, F. Yeah, maybe we could redefine a bunch of things. So what if we let K be the intersection of IF with this circle? And then we try to show How would that work? So we have to show angle KIZ is 90. Well, KAZ is, so NK is parallel to AB. Yeah, because basically, we want to show NK is parallel to AB. Let's see, is that obvious? We want to show NK is parallel to AB. You think it's an angle chase? Okay. Yeah, I'm trying to see. It feels like an angle chase, but yeah, I'm not sure. Can I? Yeah, I can join NK. So we could try to show that angle ANK plus angle NAB is 180. Okay. We can define K as IF intersect that circle. Okay. So I'm going to hide a couple things. I like that idea. So I'll call it K prime. And then basically we're going to show K prime equals K. Okay, so power of a point plus chase. So how do we do that? So we want to show that A K prime I N is cyclic, right? Do we let AN intersect IK prime, or is there like another way to do it? So yeah, I basically, oh, sorry, I did the wrong circle, my bad. We wanted, this circle. I did the wrong one. Okay. And then we show BIKM prime is cyclic. Okay. So okay. All right. So yeah, how do we show that that is cyclic? Yeah, because it feels like that should be doable, right? Showing. Let's see. Then angle KAN prime. K prime AN is. So angle ANK. Angle AIN. Oh, okay. So but wait, so that proves that ABB is 90 minus A over 2. So that shows that BK prime IB is cyclic, right? But and then we can show M lies on that. Or I guess we want to show, we need to show that BK prime IM is cyclic, right? Oh, okay. Let me delete this point. So let me draw this point right here. We know that IM bisects AE. I don't know if that helps at all. You know what? What if we use similar triangles? So DMI, I think, is similar. Is DMI similar to something? DMI is similar to DIN, I think, right? So angle DMI is equal to angle DIN, actually. And maybe that would help. Yeah. So basically, we want to show angle DIN minus 90, which, so angle DIN minus 90 is 90 minus AIN, which is ANI. So yeah, we want to show angle ANI is K prime BC. That's kind of interesting. So ANI, we want to show that's K prime BC. Oh no, that's not right. But I still think I might be on the right track. Let me think through this again. So we want 90 minus this angle, which is this angle minus 90, which is this angle, ANI. So we want to show that ANI oh. So ANI, I think we want to show ANI is equal to this angle actually. Yeah. Yeah, we want to show angle ANI is equal to angle ZK prime I. Oops. So yeah, maybe it would be helpful to draw the mixed to linear touch point.
Is this Highway of Geometry a book?
What?
Is Highway to Geometry a book?
Sorry, I didn't hear you that well. But yeah, could you type it in the
I am
chat?
asking if Highway to Geometry is a book.
Oh, if it's geometrical. Sorry, repeat it one more time. And then you can put it in the chat if I can't understand it. Oh, highway to geometry. Sorry, that's like so on his website he has a bunch of PDFs. This is just one of them. So let me send the link to it. So yeah. So yeah, there's a link to it. Yeah. So yeah, how do we calculate angle ZKI? Maybe we should let this intersect the circle again. That might be an easier way to do it. And yeah, these, so I think like in the last problem, we showed that these meet on the circle, right? Oh no, that's not true. So I'm going to delete point H, but ZK prime I would be GK prime I. Maybe that would help. Which is GNI. So basically we want to show that NA equals NG. I think. Yeah. K prime is the foot of N onto Fi. Yeah, because angle NAI is angle NK prime I. So yeah, they're parallel. Yeah. And then we're saying this angle IMB equal to angle. Yes, IMB is equal to angle INA. That was a problem I did previously on my channel. That's a well-known fact, actually. So I think that might be the key to this. That might just solve the problem. Yes. So angle IMB, we want to show it's 180 minus angle IK prime B. But yeah, so I forgot how I did this. Oh, because this triangle was similar. Yeah, okay. So yeah, that proves it. So yeah, then BK prime N equals NID in general. Yeah, so that's interesting. But yeah, that solves it. Okay. So yeah, using the lemma, basically, yeah. So actually, this problem is a little bit easier than I realized. So yeah, let me. Yeah, I don't even think we need that IK prime and F are collinear. No. So yeah, okay. So in a previous video of mine, we proved that angle IMB is INA. So that's kind of the key to the solution. And then we also have, I forgot. Okay, actually, maybe it's better to define K prime the original way. Yeah, let me define K the original way. So yeah. BK. Okay, so basically we want to show AUKZ is cyclic. And I forgot what I was doing. Actually, dang, now I totally forgot what I was doing. Actually, let me go back a little bit. Maybe I could do it this way again. What's the isosceles trapezoid? Let U equal BZ intersect the circle AIN. Okay, so we call this G. So basically you're saying rename this as G. Oh, the second intersection. And then AGIK prime is an isosceles trapezoid because how do we know that? Oh, because angle INA, we want to show that's equal to angle ING, but ING is IKG. Yeah, we don't know that this is cyclic yet, right? Oh, are we just defining K the original way? Yeah, okay. So, yeah, what if we just define K the way it was originally? And then ING is equal to IKG, which is equal to IMB. Yeah, so then NA is equal to NG. And then okay. But yeah, I already forgot how what our plan was to show that AUKZ was cyclic. I thought we had an idea, I just forgot what it was. Yeah. Okay. To show that this is cyclic, AUZK. Okay. How do we do the angle chase? KAU is 90 minus AGK. Okay. Oh. And we end up showing that that's KZI basically. KZI is half of arc KI plus NG. Yeah. So we're using symmetry because once we know this is an isosceles trapezoid, it's really just an angle chase basically. Okay. So, all right, so let's type this up. So let BK intersect AI KN at G. And then from a previous lemma on my video, we have angle INA equals angle IMB. And so we have angle INA equals angle IMB, which is equal to angle IKG. Which is equal to angle ING. And so first it's obvious that NI, so I'm going to say angle NAI equals angle NAB equals 90. That means that NU and I are collinear. Linear. And then, so NA is equal to N. Well, wait, this is not an isosceles trapezoid. So AG is perpendicular to IN, but this isn't an isosceles trapezoid, right? Yeah.
It is.
Yeah, the classes are 3 hours. So let's see. So AUKZ. So this angle, it's half of arc NG plus half of arc IK. Oh, yeah, actually, now I don't think we solved it because it's not an isosceles trapezoid. I'm not sure if we have. But maybe there's still, all right, see you next time. Oh, I know AN is equal to NG, I just proved it. Does that help solve the problem? Yeah, it's proven. Okay.
Yeah, that's true. It's easy. It's not
Okay.
even that hard. Oh, point G is the key. Oh my gosh. So like we proved that Na equals Ng, right? So
Yeah.
by symmetry we have AZU equals UZG.
Okay.
So UZG is equal to KZI,
Okay.
right? So we have
Yeah.
ZU is the external angle bisector of AZK.
Yeah.
However, UA is equal to UK, so it must be a cyclic quadrilateral.
Okay. So it's really, so UA is equal to UK, and this is the exterior angle bisector. Okay. Because angle UAK is equal to angle UKA. Okay, actually, I think angle, so you're saying angle UAK. One second, I'm thinking what Khan just said. So I get that this bisects angle AZG. I'm still, okay. So, I think AUN, okay. So, yeah, okay. So it's really that point U. So yeah, the angle bisector of, so if we had triangle AZK, then U is where Okay, so we want the angle, but the exterior, well, but it's like the external angle bisector, not the internal, but I guess it still works. Yeah. So, yeah, it just feels weird to me because it's the external angle bisector, not the internal, but maybe it's the same idea. Okay. So yeah, we've solved it. So I'm going to write it like this. So angle AZ, angle AZU is half of angle AZG. Which is half of an angle AKU is basically 90 minus half of AUK, which yeah. So AKU I'm actually still trying to, okay. I'm just going to type what BJ wrote. So AUN is equal to AKG. Now I'm just, sorry, give me just a second. I'm a little not that smart. Oh, okay, yeah. The way VJ wrote it, I think is the easiest. Yeah. So I like that. So angle AIN is equal to angle AUN which is half of angle GUN, which is half of angle, which is angle AKG. Is that right? Wait. Oh no, we want to show AUN as AKG. Sorry. So it should be like this. It should be like this. Yeah. So yeah, let me write it like this. So AUN is twice angle AIN, which is angle AKG. There we go. So that means that, which is AKZ. So yeah, AUKZ is cyclic. All right, it's time to move on to the next one. I'm sorry I spent so long on this. AUKZ is cyclic. All right. Let's see. It's twice AIN, which is twice G. Yeah. All right. So yeah, time to move on to the next one. Sorry, we spent a while on that. But yeah, it's interesting. So this problem looks kind of simple. Let's see if it's really that easy or not.